Good afternoon, ladies and gentlemen. My name is Makoto Takano, Hitachi India. Actually, I stay in Hyderabad almost for 3 years. So I have some experience in the Indian business as well. So today's my topic is waste to energy, heat recovery from waste. So by the way, how many people know about the technology of the waste to energy? Could you hand up? Okay, only some people know about waste to energy. Okay, so I will explain about what is waste to energy in detail. Yeah.
Most of them didn't get your question right. They thought how many of them knew about the company? I think waste to heat.
Okay. Yeah, actually, I want to know about how many people know about waste to energy.
So waste to energy, the technology, not the company.
Okay.
Yes? Okay,
Almost.
thank you. How many
Thank you
people know the company? Does everyone? Yes? Okay, just checking, make sure everyone is awake. Okay.
Thank you. So let's talk about our company. Hitachi Zosen Corporation is, we have developed the worldwide of the technology based on the storage capacity in the waste to energy market worldwide. Actually, our company already built almost 500 waste to energy plants all over the world. In Europe, in Japan, China, mainly in Japan and in Europe. And our net sales is 333 billion yen, like that. And our product is like this. So let's talk about waste to energy. So this is a waste to energy plant. From left side, we are talking about municipal solid waste. So this is a solid waste. That waste is collected by the municipal corporation from the city area. They pick up, and after collecting the waste from the city area, they dump it in the waste receiving area. We call the waste pit. From the waste pit, we do some mixing of the waste, because the calorific value of the waste is very low compared to the normal coal or biomass. So we want to do some equalization of the waste to keep the stable incineration in the furnace. So next, after getting the waste, we will buy the waste crane. Using the waste crane, we put on the waste in the furnace. In here, we do the incineration, and also we use a boiler to collect some energy from waste. Because we say the waste, but the waste has a lot of energy itself. I agree. The Indian waste calorific value is relatively low, even though they have more than 1,600 kilocalories per kg. So that is enough energy is there. After collecting of the steam in the boiler, we use steam turbine generation, like a normal Rankine cycle. And after incineration of the waste, we need a flue gas treatment system in later stage. Of course, after go through the flue gas treatment system, flue gases go out from the stack. We call this is a waste to energy plant. Basic idea is we want. Okay, this is our process flow diagram. You can see here boiler and the steam superheater, and go to the turbine and the condenser and coming back. We have an economizer as well. So why to combust mixed waste? Because of the not only Japan but everywhere, less landfill space is required. Because if you dump waste in the Delhi itself, I found out some area they piled up the waste like a mountain. But in case of we waste waste, we can deduct the volume less than 10%. So less land space is required. And the thermal utilization of the energy contents in the waste, that is an important thing. And no ground leakage. If you dump the waste, some leakage is go through the underground. But in case of proper heat treatment, like incineration, no ground leakage, and no controlled gas emission. Sometimes in India, we found out somewhere they are burning the waste and no flue gas treatment is there, just burning. But in case of waste energy plant, we can you can expect very well organized flue gas emission by the flue gas treatment system. And the reduction of greenhouse gases emission. If you pile the waste on the ground, from there, methane gas is going out. In case of methane gas, greenhouse gas effect is much more than CO2. If you do combustion of the waste and making power, that means you can reduce coal usage in the normal power plant. You can reduce CO2 in the power plant. So that is a good thing for this environmental view. And sometimes you can do the material utilization. For example, bottom ash from this waste incineration plant. You can use such a material for example, road basement or some cement industry. We can use it. And the reduction of transportation distance. If you bring a lot of waste from one place to another place, that is ultimately the transportation cost is very high. Instead of that, you can put on the one incineration plant somewhere and you can reduce the volume and only 10% volume you can bring to the landfill site. So many industrial countries have banned MS landfill now. And some fact about waste energy. So as I explained, sanitary waste treatment. So that means you don't see any dump yard around your living space. So improvement of the residential environment and health. And burning is a very easy technology, and mass treatment is possible, and good availability for the treatment of various waste and volume reduction. So this means waste to energy plant contribute for the improvement of living of standard. And waste to energy consider the green energy, renewable energy worldwide, and waste heat utilization and power generation, stable clean energy. So effective utilization of the unused energy. That is the second point. And the third point is greenhouse reduction, carbon emission credit, and it meets all environmental norms in Japan and Europe. So this is power generation by waste energy installation in Japan. So 2001 to 2012. So gradually the electric power generation is increasing. And now in Japan, 1,700 megawatt is generated from the waste itself. Actually, our government target is 2,500 megawatt in 2012, but that is not achieved. Actually, if we see how much power generation efficiency in waste energy plant in Japan, almost efficiency is 10 to 15% only. So actually, if you compare with a normal coal plant or oil plant, power generation plant, yeah, this figure is relatively low. That is because of the one thing is a low calorific value. Second thing is in the waste. In case of burning of the waste, you can imagine the HCl and SO2, yeah, a lot of gas. So that's why the efficiency is not good. But some of our plant, for example, this is a UK plant, and we can produce 72 megawatt from the almost 2,300 ton per day waste. That is one plant. And this is our flow diagram. And another example is this is Osaka Higashiodo plant. And this efficiency is 20%. Even though wet scrubber and SCR in the flue gas treatment system. Yeah, this one has only dry flue gas treatment system. That's why the high efficiency is achieved. But in this case, relatively low compared to UK plant. And now in India, we are developing the standard plant. We call the local plus. And we standardize the plant. The throughput is 600 ton per day. And the net calorific value is 1650 kilocalorie. And the power generation is 11.5 megawatt. In this standard project, we achieve the 24% of power generation efficiency now. And currently in Jabalpur, we are doing the first exclusion project. And next April, yeah, we can achieve the first waste to energy plant from our site in India. And the electricity power, in case of only power, we can only 27%. But if you combine heat and power, efficiency is, of course, increased 84 or 62%. And you can use some turbine exhaust or turbine extraction like this. And in case of combined cold and power, up to 50% we can achieve. Another reference of heat utilization I show. So turbine exhaust or melting furnace cooling water or boiler steam. Yeah, we can use this kind of heat, waste heat recovery we consider. Yeah, main part is flue gas and turbine exhaust is main waste heat. We have to consider about some method for this item. I will show the 3 cases. This is Hikarigaoka, Tokyo. And they use steam turbine exhaust gas for the district heating and for the greenhouses for the agriculture business. And another case is Nakatsugawa. In this plant, they use exhaust. They use a trans heat container. That means in the one facility, they use waste heat with a heat exchanger. And they put in such a heat in this kind of container and transfer 3 kilometers away from such a facility. And from there, they use this heat for the air conditioner and cooling or, such a purpose. They can use it. Another case is, sometimes they use turbine exhaust gas for the binary generation. That is ammonia ranking cycle system like this. In that case, from the relatively low temperature heat resources, you can use you can make the power generation like that. So yeah, not only power generation Rankine cycle, but sometimes we can use such a waste heat in our facility. Today, I don't have a time, so cogeneration system, this presentation will be uploaded in this organization homepage. So please see this cogeneration system from this homepage. Thank you very much.